Unless you've been living in a cave for the last few years, you're aware that autonomous cars are now a thing. Well, let's see what happens when AI-powered humanoid robots interact with self-driving cars. The power of artificial intelligence. AI is a technology that is transforming every walk of life. It is a wide-ranging tool that enables people to rethink how we integrate information, analyze data, and use the resulting insights to improve decision-making. Although there is no uniformly agreed-upon definition, AI generally is thought to refer to machines that respond to stimulation consistent with traditional responses from humans, given the human capacity for contemplation, judgment, and intention. Artificial intelligence algorithms are designed to make decisions, often using real-time data. They are unlike passive machines that are capable only of mechanical or predetermined responses. Using sensors, digital data, or remote inputs, they combine information from a variety of different sources, analyze the material instantly, and act on the insights derived from those data. With massive improvements in storage systems, processing speeds, and analytic techniques, they are capable of tremendous sophistication in analysis and decision-making. AI generally is undertaken in conjunction with machine learning and data analytics. Machine learning takes data and looks for underlying trends. If it spots something that is relevant to a practical problem, software designers can take that knowledge and use it to analyze specific issues. AI systems have the ability to learn and adapt as they make decisions. In the transportation area, for example, semi-autonomous vehicles have tools that let drivers and vehicles know about upcoming congestion, potholes, highway construction, or other possible traffic impediments. Vehicles can take advantage of the experience of other vehicles on the road without human involvement, and the entire corpus of their achieved experience is immediately and fully transferable to other similarly configured vehicles. Their advanced algorithms, sensors, and cameras incorporate experience in current operations and use dashboards and visual displays to present information in real time so human drivers are able to make sense of ongoing traffic and vehicular conditions. And in the case of fully autonomous vehicles, advanced systems can completely control the car or truck and make all the navigational decisions. Who is Sophia? Robotics has long been a significant element of the industry, and researchers have recently begun to pay attention to artificial intelligence, which has led to the creation of an AI robot. Robots with artificial intelligence are being developed more frequently today. Robotics are created to make people's lives easier. With AI, robots can navigate independently, decide what to do, and adapt to different conditions. AI robots' industrial, military, medical, exploratory, and entertainment applications are possible. AI robots need methods for navigating different settings, interacting with people, and dealing with circumstances requiring complicated semantics. Hanson Robotics created Sophia, a humanoid robot that can interact with people, display lifelike facial expressions, and express a wide range of sophisticated and sensitive emotions. It includes features for facial recognition, visual tracking, and other AI-based activities, as well as natural language processing and voice. Sophia is intended for use in research, education, and entertainment, and it aids in fostering societal debate on AI ethics and the potential of robotics. It can also be viewed as a framework for cutting-edge robotics and AI research, particularly in human-robot interactions and their potential uses in entertainment and service. Sophia, regarded as Hanson Robotics' most advanced human-like creation, personifies the potential of artificial intelligence. A platform for cutting-edge robotics and AI research, Sophia combines science, engineering, and the arts to showcase the future of AI and robotics. Sophia demonstrates how each person's conception of an AI robot differs. As a result, Sophia is regarded as the first robot citizen in the world and the first robot innovation ambassador for the UNDP. Sophia is created to have a human-sized look with a genuine human-like expressive face, patented artificial skin, and configurable skin tone, facial design, language, and arm colors. The artificial intelligence robot has a lifelike, expressive face that can mimic human emotional expressions. It can also interpret sentences in context with a cloud connection and synchronize its mouth, face, and body when speaking. The AI robot has 74 degrees of freedom in its mobility and articulated fingers, arms, and shoulders. Each hand has a payload capacity of 600 grams. Including self-navigation, Sophia has 3 distinct rolling base options. Sophia is incorporated with face detection and body tracking features. These sensors can be programmed for a wide range of physical interaction tasks. Modern research in symbolic AI, neural networks, expert systems, machine perception, conversational natural language processing, adaptive motor control, and cognitive architecture are all combined in Sophia's AI. Since Sophia's AI components can be combined in numerous ways, its reactions may alter depending on the context or other factors. In addition, it uses route planning and IK solver to control its hands, sight, movement, and dynamic stabilization for adaptive walking. Most of the time, it operates in fully independent AI mode, but occasionally its AI mingles with words created by humans. Engineers, artists, and scientists still control AI robots' conversations, behaviors, and minds. Hansen has made no secret of his ambitions for Sophia. To some, she represents the latest iteration of AI, part of a continuing process that will ultimately culminate in artificial general intelligence. AGI is the hypothetical ability of a non-human agent to master any intellectual task in the same way a human can, rather than specializing in a specific function. Sophia's AI is made up of several constituent parts, and depending on the situation, these elements can be combined in different ways, allowing for tailored responses unique to each situation. For example, Sophia's machine perception component allows her to interpret data in a way that mimics how we use our senses in the physical world, allowing her to recognize faces and pick up on emotional cues. It can simulate human psychology and different brain regions to have their own emotions. Through the application of the Tononi-Phi assessment of consciousness, it was shown Sophia might also have a simple type of consciousness based on the data processed and the circumstance. While this is a huge advancement when compared to some of the previous AI programs we have discussed, it's still a long way from general intelligence. Jack the autonomous Audi. Autonomous car technology is still in relative infancy, but most of the major OEMs, Tier 1 automotive suppliers, and many of the big tech companies have been informing the public that we should expect self-driving vehicles to show up within the next 5 years. But as often happens, getting the technology in place is only one part of the puzzle. Society has to be ready for it too. In the case of autonomous cars, both the general public and regulators are going to need to know the cars are safe. And that was the precise reason that Audi brought Jack to Washington, D.C. Jack has been doing some stellar work for Audi, but he's not an employee, he's an AI-controlled car. He was in town to show off his abilities to lawmakers in Congress, but during his time there, ours also got to experience his skills. Jack is one of several autonomous Audi research vehicles that use the A7 as a starting point. Passing it in the street, the only giveaway that this isn't a regular A7 is the red and gray graphics that wrap around the handsome sportback body. This is somewhat unusual. Most autonomous research vehicles have been festooned with roof-mounted sensors, but under the skin, Jack is packing plenty of techs. Forward-facing LiDAR scanners replace the front fog lamps, which have now been integrated into the main headlights. Radar sensors lurk behind the front fenders, and the car's existing ultrasonic and optical sensors, used for things like adaptive cruise control and parking assists, are also used to provide Jack's situational awareness. In the trunk, much of the luggage space is taken up by Jack's brain and all the data recording equipment that Audi uses to monitor his systems. From inside the car, there are a few signs that Jack is no ordinary Audi. Behind the front passenger seat, there's an LCD monitor and keyboard for the engineer who always rides along. Other changes are remarkably well integrated into the car. A small display has been integrated into the central air vent on the dashboard. A pair of buttons, to engage self-driving, have been added to the lower spokes of the steering wheel. Where you would normally expect to find a little cubby and 12-volt port ahead of the gear shifter, there's a row of toggle switches. And integrated into the dash just below the windshield is an LED strip used to clearly signal the driver what mode the car is in. Jack is not fully autonomous, which is known in the industry as SAE Level 4 or Level 5. Instead, he can drive himself on divided freeways. Sophia meets Jack the autonomous Audi. Sophia's main specialty is AI. What Sophia's outcome will be is still uncertain. But scientists and engineers have no doubt about where we want to take AI-dependent self-driving car technology. We actually want to make smart cars. You can see here to get ideas about smart car. If the ultimate goal of making a Sophia is to make a perfect human, perfect machine, then the ultimate goal of making a smart car is to make a car that runs on its own, knows all the roads of the world, and will never have an accident. It is integrated with a collective intelligence dubbed Sophia Intelligence Collective, a combination of true AI and human input. This SIC is regarded as trust between people and Sophia, in which the team mentors the AI robot through the ups and downs of its development, in the hopes that it will develop actual sentience and become an adult with human-like characteristics. It will be interesting to see whether or not Sophia can behave in a similar way with a self-driving vehicle that is in fact more like her than any human. Sophia can use its real AI to create some of its own thoughts, speech, and actions. Through her contacts with people, Sophia develops and uses this invaluable knowledge to achieve genuine autonomy and sentience. So will she be able to apply the same information and behavioral tactics to another AI-operated robot? That's all for today's video. See you next time.